Hello class. Yeah, how are we? Now we are back in another discussion, and this is topic 6. See, it's a bit longer. Topic 6, and this is elements, compounds, and mixtures. See, and mixtures. Now we are going to isolate each by each. We shall make sure, look at elements alone, compounds alone, then mixtures alone. See? Now, let us speak out elements. That means the subtopics will be sincerely elements and compounds, each looked on its own, then mixtures. Let us speak on elements. See? Elements. See? Now, chemistry, you see, when you are looking at chemistry, you need to understand it. See? Because the language of the subject is very, very important. Those terms, if somebody says any element, you should be knowing what they are talking about. Now, before you look at the element, let me refer you back slightly to the question I posed in one of the topics here. I posed the question that matter, you see, we said all things is matter. Now, matter has a very unseen part that makes it up. See? We said that matter has a building block which we can not see, but so many of those unseen particles join to form a seen substance called matter. So, now, listen. Who can remind us, what did we say the smallest particle that makes up matter was? Yes, patience. An atom. That's very, very correct. That an atom is the smallest part of matter which can't be seen. See? Now, listen here now. When we say an atom is what makes up matter, see, simply an element, see, an element has a basic unit called an atom. Listen very attentively. When we are talking about an element, we are simply meaning the atom. Let us put it like this. See? So, it's like I get a tin having a tin. So that means here atom, then element itself. So it's like when you have a tin containing salt inside. See, the tin houses salt. The tin is the house of salt. What is inside here is salt. Then this would be the atom, and this is the element. So, that means the element and the atom is the same language. In other words, we can always say an atom of an element. Take an example. See, sodium atom is an atom of sodium element. See, that means that the material that makes up any element is what we call an atom. See? Now, that would sound, that's layman is understanding that the material, that an element is basically, its material is an atom, and matter consists of elements. See, that matter is consisting of an element, but as we say that the outside cover is the element, then the inside is the salt, but it's a single thing called a tin having salt. Therefore, an atom is we mention it that an atom of an element. But in chemical terms, we can simply be more clear by saying that an atom, see, we first of all said it is invisible, and we built it from the fact that when you break down maybe charcoal and you break it into tiny pieces and more tiny until you realize that you get dust, and from dust you see nothing. See, when you reach the extent of seeing nothing, then you have obtained an atom. See, it is an invisible particle. See, that means when you have reached a point where you can't divide anymore, then you have attained an atom. You can't divide anymore because you can't see what you are dividing. Therefore, an atom is the smallest indivisible, can't be divided. See, a smallest indivisible particle of an element. That means the element is the shell, the outer covering, inside is the atom. So, is the smallest indivisible particle of an element which can take part in a chemical reaction, in a chemical change. See, that chemical changes are brought about by elements reacting with other elements. See? Now, let us summarize it this way. Now, an atom can't be seen, see? And it is the point that when you divide the seen substance until you get what's unseen, you have got an atom. So, now, by attaining an atom, you have attained the material for the element. See, because an element can be seen now. You can see the tin, but you can't see salt inside. See, now, an atom is the smallest indivisible particle of an element which can take part in a chemical reaction. In other words, in a chemical change. What brings about a chemical change is that atom of the element inside. The tin cannot react. It is the salt which is important. Now, an element is a substance. See, is a substance that cannot be split down into two or more substances. That's simply speaking of itself. An element is that substance that cannot be split into two or more substances. See? Yet the atom is an indivisible particle. That means when you are talking about an element, you are talking about an atom at the same time. But it's just we have two distinctive, two differences. The differences are the definitions, but an atom is the element, because an element, inside the element is the atom, is the reacting part of the element. That's it. Now, see. Now let us draw down onto what we call, there are some substances here that can contain, can contain one element or one atom, so, or can contain different atoms. We are going to look at so many elements here, but let us first look at what we call the term pure substance. We have three terms: atom, element, pure substance. See, now, so when do we say something is pure? Can somebody remind, what does the English mean when they say this thing is pure water or pure something? Is pure? Yes, Patience.
I think it means when that pure substance doesn't have impurities.
It does not have impurities. Do you have alternative? When something is not contaminated with the impurities.
Yes.
See, and that means when something is alone, not so. A pure substance is one containing one type of particles that make it up. It contains, and we are saying the word particles here means atoms. See? Means atoms. Or means elements, but elements is big. Now, that is finished. Now, shifting very fast to remind you. Earlier, in the early centuries, many scientists took interest in finding out elements on Earth. And as we talk now, they are beyond 110. They are beyond 110 elements. I mean, more are still being discovered. See, that means I'm waiting for you to discover for us some elements. Now I'm giving you a table here which was discovered by a Russian scientist called Mendeleev. A Russian scientist called Mendeleev. This table of elements that are on Earth was discovered by a Russian scientist called Mendeleev. Now, there are so many elements on Earth. I've told you there are over 110, and more are still being discovered. See, now look at that table. It was given a scientific name called the periodic table. Periodic table. See, now in that table you realize that they put the name of the element, the name and the symbol. Clear? Do you see name? Like you are seeing, they are putting there helium somewhere, and they are putting HE. If you look at the tops, you are looking at hydrogen, then they are putting H. See? See that? Now, listen. In this subject here, we said that this element which you are talking about is what reacts or mixes with another element chemically to change into a new substance. And that change is called a chemical change or a chemical reaction. So now each element has been symbolized. The element can either have one letter or two letters. Now, when it's one letter, we use a capital letter, capital H. When there are two letters for that element, the first letter is capital, the second letter is small. So, now, at this level of ours in senior 1, we shall only be allowed to practice the first 20 elements, but you are not denied to practice more. Now, the first 20 elements we shall get for ourselves a word to remind us. How do we remember the first elements? Because we shall be required to write some symbols of some elements and their names. See, now, examples of first 20 elements. First 20. I will request you to look at your periodic table and give me those elements from the first one, where you see number 1. Which element is that?
Hydrogen.
Hydrogen.
Yes.
Hydrogen. Hydrogen. Next.
Helium.
Helium.
Lithium.
Lithium. Beryllium. Boron. Carbon.
Nitrogen.
Nitrogen.
Oxygen.
Oxygen.
Fluorine.
Fluorine.
Neon.
Neon.
Sodium.
Sodium.
Magnesium.
Magnesium.
Aluminium.
Aluminium.
Silicon.
Silicon.
Chlorine.
Chlorine.
Argon.
Argon.
Potassium. From silicon we have phosphorus.
From silicon there is phosphorus. Then potassium.
Then calcium.
Calcium. Those are the first 20 elements. We can master them for now. Now, there is sulfur first. There is sulfur. Then there is chlorine. Now, let us put their symbols according to that periodic table you are seeing. Hydrogen is capital H. One letter is capital. This one is HE. From our periodic table you have there. Lithium is Li. Then beryllium is Be. Boron, capital B. Carbon, capital C. Nitrogen, oxygen, fluorine, neon, Ne. Then sodium, magnesium, aluminium, then silicon, then phosphorus, capital P, sulfur, chlorine, Cl, then argon, Ar, potassium, K, calcium, Ca. Clear? Now, I think we can see if there are two letters. First letter is capital, second letter is small. That's right. Those are the first 20 elements, but you can have a word that makes you to remember. Which word can make us remember this? We have any? Can we derive some words here? Yes. Hi. Henry. loved biology because chemistry never objects fellow new students mind you
is what?
here mind you are some potential survivors capable and kept calm. Yeah, thank you very, very much. I, Henry, loved biology because chemistry never objects fellow new students. Mind you are some potential survivors capable and kept calm. Thank you. Those are the first 20 elements, and those elements are very important in reacting with other elements to form new compounds. And the reaction between two or more elements to form a new compound is called a chemical reaction. Now, that's about elements. We are leaving that part alone, dropping very fast to a compound. Compound now. A compound. See. Now, compound. A compound. Now, the word compound in English means what? What does the word compound in English mean? Compound. Not the compound at home. Compound. Compound meaning. See? So the compound is the meaning. Compound meaning is the meaning for all things you are talking about. See, if I say compound, it is a statement for all things you are talking about. Now, let me point you back a little. We said that when a chemical change is taking place, then a new substance is formed, and the reaction that led to a new substance is called a chemical reaction. And that chemical reaction came as a result of two or more elements coming in contact with each other chemically, not mere putting two things together. Because we said for a chemical reaction to take place, there must be heat energy, not so? Now, if any elements in these come together and you heat, then a new compound, a new substance will be formed. A new substance being formed after a chemical reaction is called a compound. See, called a compound. Now, in direct statement, a compound is a substance that consists of two or more elements which have been combined chemically. That means you cannot talk about a compound if elements were not combined chemically, and we say to be combined chemically, is some form of energy must take place. See? Like we referred to a certain reaction here, a certain reaction that involved magnesium plus oxygen gave us magnesium what? Oxide, not so? This is an element combining with an element via what we added the energy as heat. Then we go to what we called a compound. See? Now listen. This because we said earlier that when a chemical change occurs, and a chemical change is called a chemical reaction. When a chemical reaction occurs, you cannot reverse it. See? You can't reverse it physically. But of course you can do it chemically. See, magnesium can be split down back into this. Chemically, a compound cannot be split by any chemical, by any physical means, but you can split it back by chemical means. So, yeah, that's very, very correct. Now let us give just a few examples of some compounds, and we've said for you to know that that's a compound, then it should have two parts or more parts. It should have parts of two or more elements. But by observation, this element was gray. Earlier on, when we burnt it there, it was gray. We burnt in a colorless gas that we did not see, because we weren't seeing oxygen. No. But we say, the scientists say those particles are present. Therefore, we believe oxygen was there because they proved that it's there. And this substance was what? White. Now, that would tell you that when a compound has been formed, then it does not have a similar look to its elements that formed it. Did you see that? There is no similarity between magnesium, which is gray, and magnesium oxide, which is white. Examples of compounds. Just we shall give like some 4 examples. There are so many. Now, the elements are, listen. To your attention, I told you that there are over 110 elements. Over means beyond. Now, to your attention, those elements, see, those elements are, again, most of them are in a category called metals. Most elements on earth are metals. See? You realize that very, very few, like a third of the entire elements on earth, a third are only metals. A third are non-metals, are not metals. See? Now, coming back here, we said the more the elements are on earth, the more the compounds are. Now we have seen one example of the compound. Here we have seen what? Magnesium oxide. You can have many for us. anything that sounded to you to have two elements. See? Sodium oxide. Yes, especially you mentioned the chorus answer. See, she's refusing. Carbon dioxide, does it mean it is made of two? Now when you are saying carbon space must be there between the words. Carbon dioxide, yes. Ammonium chloride. Now for the interest of time, we shall only give those. There are so many when elements combine. So now that is closing the gap for compounds, dropping down to mixtures now. To mixtures. Now, as we drop onto mixtures here, I told you that let us try to focus there first. Now, we have seen an element, and we have seen that an element must be a substance that cannot be split into more. That means it must be made of that basic unit called the atom, because an atom can't be split further. But before mixtures here, we have to see something called the what? Molecule. See? Then it will take us a drop into mixtures, because we can't leave out a molecule. See? Now look here. Look here. A molecule is again the smallest unseen particle. Is the smallest particle again. There you are. See, that makes up either an element or a compound. But in this case, for it can exist as alone on its own. It can exist in what we call a free state. What's to mean by molecule? It is the smallest particle of either an element or a compound. See? So that means when you are talking about elements, there are those elements which are called molecules, and there are those elements which are called molecules, and there are those compounds which are also called. So now, to be very, very brief here and more clear, to know that substance is a molecule, then the basic identity, they are majorly gases. See, in the case of the element, and they can be either gaseous or liquids if they are compounds. So how do I know that that's a molecule? If we are talking about a molecule in terms of an element, it should be a gaseous element. Oxygen, gas, oxygen, molecule. See? Then if you are talking about a compound and you want to refer to a compound which is a molecule, then it must be either a gas or a liquid. Carbon dioxide molecule. It is a compound, but a special compound which is a molecule, must be. You can't say magnesium oxide is a molecule. No. That's solid. See? Molecules for a compound are gases or liquids, but molecules for elements are gases only. See? Period. That's very, very true. That's why we are saying a molecule is the smallest particle, is that special smallest particle of an element, but in a form that is gaseous. Then if the compound has a gaseous form and a liquid form, then it has molecules. See, a molecule is the smallest particle of an element or a compound which is capable of existing in free state or and separate state. Free and separate. See. Now, let us go to the mixture. Because of time, we need to keep time. Mixtures. So, mixture. Now, you see, chemistry is very, very rich with words. It's very, very rich and interesting. Listen, let this be at your attention as I move. We said element. Now, you see, I've been breaking down element, see, atom, now compound, molecule, now mixture. Remember, I said the compound is a substance having two or more elements that have been chemically combined. Now, a mixture, so a mixture is a substance having two or more substances. Now, listen, see, is a substance having two or more substances. Now, what it has here is either elements or compounds which are physically combined. Oh, that's very, very need to really understand it. We're saying a mixture must be a substance having two or more substances, and which substances are they? Either elements or compounds which are physically now listen. What do we mean by to be physically combined? Is to combine them without no energy input, see, without forming a new substance per se. See, like salt plus water, salt plus sand, you get sand plus salt together. Yeah. Salt in its container plus sand in its container. You are still getting salt plus sand, but in the same. See? There is no any chemical reaction or chemical change that has taken what? Place here. That means they are combined physically. To be physical, something physical is what can be seen, tested, or felt by hands. When you say a physical change, a change which you can isolate by your eyes, hands, ears, see. Now, that's very, very correct. Now, listen. Now, I've paused there. I want to take you down now here to what we are going now into, what we call types of mixtures. And in the types are we are going to isolate the types together. Types of mixture. Now, could you, in the discussion of these types, give me some mixtures that you would make, that you are able to make on your own? At least discuss over some and say, I'm able to mix this and that will be my mixture. Then we shall categorize them as types and we see. Okay, can you pause down to get now several examples of mixtures that you would make? Examples of mixtures, or discuss them down and one person present them, types. Have you finished? Yeah, let me have one of you present those examples. Then we shall have types, examples with that. Yes, as per Elijah, examples.
Iron and sulfur.
Iron
And sulfur.
iron and sulfur, iron filings and sulfur.
Then you mix the sand and salt.
Sand and salt. Then
You mix your sugar and water.
sugar and water.
Then you mix your water and oil.
Water and oil.
Then a mixture of like juice and these seeds.
Juice and
Seeds.
seed and what?
Seeds.
Seeds.
Then also air.
Air. So air. Thank you very much, Asporo. Now Now from these categories, we can try to form types. What would be this? Solid and solid. That means solid, solid what? Then this is still solid, solid. Then this one, solid what? Liquid, solid, liquid mixture. Then here, liquid, liquid mixture, liquid, liquid mixture. Then gaseous mixture. So gaseous. Now let us look at each type and example and the methods. Each type, example, methods. Each type, example, and the methods. So now we say then the methods. See. Now we would also have a part called the reason for using that method. Reason. Yeah, reason. Reason. Now, we started with the, let me have the first type, solid, solid. Solid, solid mixtures would have which one? Iron and sulfur. And sulfur. Method used to separate iron and sulfur? Magnetism. Use of magnet or magnetic method. Magnetic. Pensions, are you together? Under the magnet. Now we are saying iron sulfur, we can use a magnet. Why? Why do you use a magnet?
Because the iron is a metal and magnet can attract.
Because iron is a metal and magnet attract what? Metals. Now you gave me what other solid here? You said sand and what? Sand and salt. Which method would work there? Sand and salt. Sand and salt you decant? Say it again. Dissolve. You dissolve in water. Then you filter. But when you filter, when you dissolve in water, salt will dissolve. When you filter, you remain with sand and salt water. How do you gain your salt? You evaporate to dryness. That means you use filtration followed by evaporation to dryness. Not so? Then what else is the mixture? Another mixture here? Let me also add you one here. Iodine and salt. What method is that?
Sublimation.
Why sublimation?
One can sublimate and the other can not.
Because who can sublime? Iodine sublimes. Okay. Now let us go to another type here called what? Solid liquid. Solid liquid mixture. Which one is that mixture? Solid and the liquid, you do mix what and what? That will be tea leaves and tea.
Yeah.
Tea leaves and
Tea.
are they different? Tea leaves and tea. That sounds That sounds. Can you give me another example of solid and a liquid? Water and sand. Which method is that? Yeah. Water and sand. Yeah, and we need to separate it by filtration. They are not so. Sand. Some sand. Yeah, sand. Sugar and water. Won't they dissolve and mix in each other? Sugar and water. Yeah, that's very good. Now, these ones will mix and dissolve, but these ones will not dissolve. Not so? How will you separate sugar and water after they have dissolved? That means you must make sure the solution gives you back the solid. Now that scientific method of making a solution to produce for a solid back is called what?
For making a solution? Because
now we are saying when you put sugar in water, it goes into it, but you need that solution to produce for you your sugar. Evaporate to dryness. Have you ever done that? If you evaporate tea, if you put tea in the cup and put sugar and try to boil and collect the vapor, does it leave sugar behind? Evaporation to dryness, does it leave for you? This one, you say this was filtration. Eh? Now I'll need you to demonstrate this one here. How do you filter a mixture of sand and salt? Sand, but you must show us how you fold the filter paper, how you organize the experiment. Now let us first look at separation of sand from here first. Capture that retort stand and support the separation of sand and water. Sand and water by filtration. Now put that then show us how you fold the filter paper, how you just to around 200 cubic centimeters of water. You add 200 cubic centimeters of water. You add 10 spatulas of sand. 10 spatulas of sand.
Then you add 2 spatulas of
10.
10. 3, 4, 5, 6, 7, 8, 9, 10. So you now mix your sand and water.
Then you incline.
So we have to separate these two. So we're going to separate sand and water. So we're going to separate the water from the sand using filtration. And filtration use a filtering funnel. So you get a filtering funnel, you place it, you support it using the clamp sand, place it above the container into which you're going to pour the water. Then you get a filter paper, and this is how we fold it. Fold it halfway like this. Then again you fold it like that. Into equal dimensions. So, one and two. Then you put your filter paper to the filter in front. Then you go, get your mixture of water and sand and pour. Again. So the water will come this way slowly, pour slowly.
Yeah, I think the water is going through the filter paper, not so? Now, for the interest of time, we would realize that okay, we can leave it from there to finish later. Now, when you look at that mixture, the sand, water is seen going down, but the sand will remain on the filter paper. Now, when sand remains on the filter paper, we give it a special name here. And also we give this a special name. Now, what's the name given to the what remains on the filter paper? A residue. Then what goes down through is the filtrate. Thank you very much. Now, finishing up our mixtures here, what other method could we separate water and sand? Only filtration? Could that be the only method? Would decant, wait for it to settle and pour it carefully. Not so? Decant. Sugar and water we would evaporate to dryness. Evaporation to dryness. Evaporation to dryness. Yeah. But the other way we would use even simple distillation would totally give us pure water. Simple distillation give us pure water. Now we have so many mixtures. Do you have some more mixtures apart from here what we've listed here? Because now we are summarizing our lesson. You gave me air. You mentioned the air.
On this one?
Yes. Tea leaves from tea. Yeah. Tea leaves from tea. How do you separate that?
By decanting.
Decanting or filtration. Yeah. Now air. Did you know that air is a mixture?
Yes.
Air is a mixture. Now, how do you separate the mixture, the substances in air? Air is a mixture. How do you separate substances in air? In air. Air has what? Which components are in air? There is nitrogen, oxygen, carbon dioxide, rare gases. Then you said hydrogen, pollutant gases. This type is a gaseous mixture, not so? What method do you separate those things by, those components in air? Yes, Aspolo?
Fractional distillation.
Fractional distillation. We shall see it ahead there. When we are looking at air as a topic, we shall isolate what's fractional distillation and how air is split down into its components. Which other mixture can be separated by fractional distillation here? Yes, Aspolo.
Petroleum.
Yes, petroleum. Which things could petroleum give us? What's found in petroleum? Diesel. Diesel. Paraffin. You call it kerosene. Kerosene. Petrol. Yeah. All these can be separated. What's the reason for using this method?
Okay, it's used to separate mixtures where the substances, the mixtures, oils and so on, they have different boiling points.
It is used in cases where the components have different boiling what? Points. One boils faster than the other. Now, my interest would be very much on this diagram for fractional distillation that can separate these components here. That can separate those components. In the laboratory, which mixture can we put together here to separate it by the same method? Which ethanol and water. That means those ones have this boils at 78, this boils at 100. Who would move out first? When you separate them, ethanol would move out first, leaving water behind. Now, fractional distillation is carried out in what we call a fractionating column. Now, in that experiment, we normally have our mixture put in a round bottomed flask here, clear. Then we have that fractionating column connected to the mixture, joined by the corks. Then on that fractional distillating column, we have that part that lets out the liquid, and we have a cooling section here called Liebig condenser. That apparatus called what? Liebig condenser. We supply water from here and water goes out from there. Then inside here there are glass beads, or sometimes they can put anti-bumping stones, glass beads or anti-bumping stones. They increase the surface area during distillation. Then there is that thermometer to tell us the temperature and who is going out first, fast. Then there is your tripod stand here. Then this flask is clamped by a retort stand. Then here we collect our, what do we collect here? See, now you see, when we filtered using the funnel sand and water, we had a residue and a filtrate, clear? Now when we heat a mixture of water and ethanol will rise up first, and the water, cold water in, then here cold water out. Now cold water in here, when water is flowing, you don't put water from here. Water must enter from here so that it saturates uniformly and cools the vapor that is coming here to form a liquid here. Now what comes here will be ethanol. Now ethanol will be called a what? Ethanol will be called a distillate. Then the water will be called a residue. Distillate, residue. There we had what? Filtrate and residue. Now that takes us now to the last session of this discussion, and that will be solutions. There are many methods, but we've only talked about a few. And we've talked about sublimation, fractional distillation, magnetic separation. Now we've left out talking about using a separating funnel to separate mixtures like oil and water, those that form two layers. But before we dwell on solutions, let us first clear the air on some important terms on liquid mixtures here. We clear some air on liquid mixtures. Now, liquid mixtures here, let us first clear some air, liquid mixtures. Now we have two types of liquids here. We have what we call miscible and what? And immiscible. Miscible and immiscible. Now the word immiscible is simply dissolve. Yeah. When you are using dissolve is when a solid mixes with water to form a solution, we call it dissolve. But the dissolving of a liquid entering in another liquid is called miscible. The liquid didn't dissolve, but the liquid was miscible with another liquid. Did you hear that? Yeah. That miscible liquids, they mix with each other to form a uniform solution, meaning there are no two layers formed there. That is your ethanol and water. See? Immiscible liquids, on the other hand, when you mix them, they will form two separate layers. That is your water and oil. See? And those that are miscible are separated by fractional distillation. Then those that are immiscible are separated by a separating funnel. That very, very right. Now, in summary of our lesson, we said here immiscible liquid, and we've seen that. Then lastly, solutions. Solutions. So, yeah. Solutions. What is a solution? This is your part now. What is a solution? And I've told you that a solution is formed either when liquids are alone mix or a liquid and a solid. When a liquid is mixing with a liquid, you said the liquid is miscible with another liquid. Ethanol was miscible with water. You don't say ethanol dissolved in water. It would be correct, but the better word would be was miscible. But when you say a solid dissolved in water, you don't say a solid was miscible with water. A solid must dissolve, but a liquid is miscible with another. See, the two mean the same. Somebody discuss for us this session what's a solution, then what's a solute, what's a solvent, then types of solutions. You are discussing solution, solvent, solute, types of solutions, and that will be the end of our session. Can somebody take over? Take over, whether you take over one or two. Yes, Patience, discuss some. What are you discussing?
I'm discussing solvent and solute.
A solvent and a solute. Okay, go ahead.
When a mixture is taking place, there is always a solvent and a solute. So, the solute is the solute. Okay, like a solvent is, let me give an example like water and salt. You get salt and mix it in water. Now that substance is used to mix, let me say the liquid is the solvent, and that solid substance is used to mix with the solvent, with the water. Let me give an example, it's the solid. Now let me give an example. As we did here before, sand and water. Sand was not able to dissolve in the water, so it's not a solid. Now, if I get, let me say, now the potassium permanganate we mixed earlier, we mixed it with the water, it dissolved, and we could not see the potassium permanganate anymore, but the water was the one which we could see just because it was sparkling in color. So, the potassium permanganate was the solid, and the water was the solvent.
Okay, thank you. To me now, what would you say a solvent could be defined like? Or as?
A solvent is a liquid substance used to dissolve two or more substances in a solution.
Yes, a substance that is used to dissolve two or more substances. That's right. Then a solute?
Solute is a
that dissolves in a solvent.
Yes.
That's right. Who can discuss what's a solution according to her? What is a solution? Yes.
Okay. We have seen that a solution can either be formed by a combination of two miscible liquids, two or more miscible liquids, or a solution can still be formed by the combination of a solvent and a solid. So I can define a solution to be a substance that is formed by the combination of, by dissolving a solid in a solvent or combination of two or more miscible liquids.
Okay. Now, yes, let's hear from Juko first.
The solution is the uniform mixture of two or more substances.
Say it again.
The solution is the uniform mixture of two or more substances.
Now, is a mixture of sand and water a solution? No. It's a mixture. That a solution you are saying is also a mixture, but the only identity to a solution is that it must be uniform. It means something should not be appearing in it as a solid. Is that very, very right? See? Now, types of solutions here would be let us pick it from here. Then somebody takes us through. If you got 1 teaspoon of sugar in a full cup of water, of hot water, does it dissolve? One teaspoon of sugar in a hot cup of water, it dissolves, not so? Then if you added and continued adding, and they became like 6 or 7, will they dissolve? They dissolve. What if they are 10? They'll still dissolve, even if they are 20. See? Now, types of solutions here. Types of solutions here. Now, I saw a hand raise up here, but that hand, I'm requesting that hand to help us to add we are going to ask him to add ammonium chloride to water to only 50 cubic centimeters of water. 50 cubic centimeters of water, add ammonium chloride. Add ammonium chloride slowly until you tell us whether it has refused to dissolve. Make it 25 cubic centimeters of water. Make it 25. Slowly. Slowly. As stir using the same spatula. Keep adding. Has it dissolved?
Yes.
Still dissolved.
Yes.
Just still dissolved. Still dissolves. Now, for the interest of time, you can stop there. Can stop there for the interest of time. Now, if you continue to add, there will reach a time when no more dissolves, and it will just stay at the bottom of the beaker. Now, that would call us to getting our solutions. It does not mean that the solution which you have got when the solid is no longer dissolving is not a solution. From the first time it was already a solution. Now, somebody raised up a hand to discuss the different types of solution there. What were those? What were those? Yes, let me have you discuss the types and even give us their meaning. That very right? Yes, Asporo, take over the different types as we close.
We have a saturated solution.
Saturated.
Solution. We have a unsaturated solution. And we have the supersaturated solution.
Could you take us through what do they mean?
Unsaturated solution is a solution which cannot dissolve more of a solid at that temperature, the presence of undissolved solid.
It cannot dissolve anymore.
Yes.
Okay. That is
The
saturated solution will refuse to dissolve more. Okay, go ahead.
The unsaturated solution is a solution which can dissolve more of a solid at the same temperature in the presence of undissolved solid. Then a supersaturated solution is a solution
Okay, you've given us the first two correctly.
a solution which contains more solid than, which is having more of a solid than it can contain at that temperature.
Exactly.
That is the supersaturated solution.
Yeah. Now let us summarize it. Thank you very much. a saturated solution. A solution is a uniform mixture of two or more substances, which is a solute and its solvent. Then a solvent is that substance that can dissolve other substances. Then a solute is a substance that dissolves in the solvent. Then went to the types. You said saturated, unsaturated, supersaturated. Now, at the start of adding a substance in water, like when you are adding salt in water, the first spatulas you add, they will dissolve. That solution is not yet saturated, is not yet satisfied. It will continue to dissolve more. But there reaches a time when you are about, see, it reaches a time that you add and it refuses to dissolve. That solution you get that is no longer dissolving more solutes is called a saturated solution. A saturated solution is a solution that cannot dissolve any more solutes in the presence of undissolved solutes, in the presence of already the solutes that have refused to dissolve. Then a supersaturated one is that one that contains more solutes than it should have at a given temperature. So that would just mean that it's between saturated and ani. When you are adding spatulas to water, the spatula which refuses to dissolve, that instance between refusing to dissolve and the dissolved spatula before this one refuses to dissolve is what we call supersaturated. Okay, now we would end there for this session. We went through elements and we looked at atoms, molecules, pure substance, and we said the pure substance is identified by only one type of particle in it, and the pure substance can be tested to be pure using its physical properties like boiling point, melting point, and its density. Then we went ahead to look at molecules, compounds, and lastly mixtures. Then finally we have seen solutions. Now at the end of this lesson there is an activity of integration, which is this one. Let me read it for you. The activity of integration. To gain an understanding of mixtures and the concept of separating mixtures, to gain an understanding of mixtures and the concept of separating mixtures, and the concept of separating mixtures, prepare an article to help. Prepare an article to help. Feeding mothers in your community, to help feeding mothers in your community. To find iron, element in iron fortified breakfast cereal. Iron element in iron fortified. Iron fortified. Iron hyphen a small dash. Iron fortified cereal flakes. Cereal flakes. Cereal flakes. Then continue. Cereal flakes. Iron fortified cereal flakes. Through this article, the mother should be able to see, the mother should be able to see how iron component, of this cereal mixture, retains its properties and can be separated by physical means. Then classroom research work. That's the activity of integration. Then this is research work for the class. Discuss the differences between mixtures and compounds. Yeah, that's the end of our session. We shall meet in the next lesson.